Good morning, my name is Cameron and my project has been on biochar, a high value product that can be made from forestry harvest residues. The question is this an economically feasible thing to do? I wanted to help answer that by modelling the cost of in-forest biochar production. The intention is that the costs and considerations in my study can be used by forestry companies for a head start on a biochar business case. Today I will answer the questions of what is biochar, why make it, how we can make it, and what that will cost. So what is biochar? Have a look for yourselves. Chemically, it's exactly the same thing as charcoal. It's 80 to 90% carbon and incredibly porous. A single gram of biochar has a surface area the size of a basketball court. It's also pretty lightweight, so oven dry bulk density of 100 kilograms per meters cubed, so 4 times lower than that of the wood from which it was made. So what's the difference? Formally, it's charcoal when it's intended for burning and biochar when it's not. So if not for a fuel, then why make it? Firstly, biochar is used for problematic slash. Biochar can be made on the landing and can provide a 10-fold decrease in slash pile volume. Even if that slash is fully green and covered in mud, there's a biochar production technique and market to suit. The industry desperately needs economic, not just regulatory incentives to get slash off the hillside. One important property of biochar is that it's not biodegradable. Its carbon can last for thousands of years. By turning some slash into biochar, net CO2 removals are possible from every rotation. While these removals are not yet recognised by the ETS, they can be sold on voluntary carbon markets. At the moment, you would get about $500 for making 1 tonne of biochar, and that's just for the carbon. There's additional revenue to be made from the physical biochar itself. Biochar is a highly versatile product, but is most commonly used as a soil amendment where it doesn't fertilise directly, but creates conditions for increased fertility through its porous nature. It can also, in some cases, decrease the soil methane and nitrous oxide emissions. And it can be used in building products like concrete and asphalt and upgraded to activated charcoal where it's used in some supplements and cosmetic products. The New Zealand biochar market is still developing, but there's no reason that it shouldn't catch up to the Australian and American markets, where 1 tonne of biochar should fetch around $800 as a soil amendment and up to $10,000 to $20,000 in some specialty markets per tonne. So, and also think about the extra value of not having your slash wrapped around a bridge or and the clean green image you'd be able to promote as a forest owner. So it's clearly good stuff, but how do you make it? I investigated 3 of the most promising techniques for use in New Zealand forestry, and you'll love what they call them: the char maker, the char boss, and the carbonator. So here's how they work. The char maker is a batch pyrolysis technique. So you take your slash, load them into these big steel cages, load the cages into an airtight, insulated 40-foot container, and then bake at 600 degrees for 7 hours. You pull out your cages filled with biochar and dunk them into a tank of water to prevent the char from combusting further once it's exposed to oxygen. The other 2 methods, the char boss and the carbonator, are 2 different sizes of air curtain burners. It's basically a big firebox, so you set your slash alight with, they recommend, I think, 3 gallons of diesel and a propane torch. And yeah, so it's a big fire, and the burner blows a curtain of air across the top, which helps fuel the fire and recirculate smoke back into the flames, so it's a super clean burn. As it goes through its char phase, the burning wood falls through a grill at the bottom of the firebox, where it's then extinguished by water. My next job was to find out what these 3 options cost to run. Firstly, I came up with the equipment requirements for supporting each operation. So you need something to load it and unload the char, something to transport water around in for the quenching, something to take the biochar back to market in, and a crew to do the work. Using an Excel-based costing model and some figures generously provided by industry, I came up with a day cost for each element of the operation. I also considered the operating and overhead costs as well as equipment transport between landings. I assumed a 50-kilometre distance from market, which is the one feedstock distribution parameter that had a significant impact. And assumed a 50-kilometre daily commute and got the following results. So comparing the char maker, char boss, and carbonator, each operation has a capital cost of, so it's the full purchase price of each piece of equipment, and that's included in a day cost. So the depreciation and financing is all included, as well as the running costs is included in that day cost. So you can see the carbonator is the most expensive, followed by char maker, then char boss. Where it gets interesting is when you include some productivity estimates and look at the unit cost for biochar production, then it's clearly the carbonator is the best value. So I mentioned before that if you include the carbon credits and selling the physical biochar itself, you could get about $1,300 per tonne. So yeah, to put that in perspective with the cost to make it, the char boss doesn't seem to add up. It's just too small a scale for a New Zealand forestry application. But the carbonator is looking like it could be a profitable operation. The char maker, while it's not quite breaking even at $1,300 a tonne selling price, it actually produces the high quality char, so has potential to access those high value markets. So what's next? Firstly, for the air curtain burners especially, we need some New Zealand specific trials for more certainty on those productivity figures. There was a degree of uncertainty in my estimates that you'd ideally want to bring down if you were relying on biochar revenue to fund the operation. We also we need to test the yield and the batch time or throughput of the different operations with different feedstock piece sizes and moisture contents, which have a big impact on the throughput. While I costed each method as a standalone operation, so coming in 6-12 months after the harvesting's been completed, there is potential for integrating these methods into harvesting operations. So, for example, a crew could put their daily offcuts straight into the char maker cages, load it into the chamber, and set it on a timer, come back in the morning, and it's ready for quenching. So, yeah, you gain a lot of efficiencies there by using machines that are already there and labour. Did a quick calculation for that case, and you would halve the production cost from that $1,400 down to $700. So, and yeah, in addition to that, if you did that daily, the crew would never accumulate slash, so it could be reduced landing sizes there. There's some additional production methods which I wasn't able to investigate, such as flame cap pyrolysis, which is a low capital, low tech method, and some high tech methods that can create electricity at the same time as producing biochar. So you can plug in your electric charters like Campbell was showing us the other day. So lastly, we need to help develop market opportunities. The New Zealand Biochar Network is a great group for educating and connecting potential buyers and sellers. So well worth joining up to stay up to date with everything going on with biochar in New Zealand and in your region. And to conclude, my project has shown that biochar is a genuine solution and opportunity for New Zealand forestry. So watch this space.